We start now. Rakshita, please read it. So there are some situations where we cannot apply the parametric statistics because the parametric statistics require some of the basic assumptions of normal probability distribution and typical type of sampling frame, but sometimes that is not possible for us. Sometimes we have collected data from the secondary sources also. So in that condition, we may follow the non-parametric statistical test. But keep in mind that is when you want to do the non-parametric statistics, your DF that should be very high. If the DF is very low, then there is high probability for the biasness. Therefore, you have to design the test in such a manner so that you can get more number of cases for different types of categories. And another part of the non-parametric statistics that it has less assumptions. Assumption is relatively less because this model does not follow the normal distribution, but it follows the degrees of freedom distribution. That means when your categories or when your DF is 30, then you will find that is the distribution, that is the chi-square distribution that will be close to the normal distribution. So always keep in mind that is there will be more number of classification. And for each classification, there will be more number of data. Therefore, this model is very much useful when you are dealing with the big data. Next. Next, Rakshita. So there are different types of already discussed, that is the parametric and the non-parametric. Between subject t-test, that is the parametric test, but in case of the non-parametric, it will be the Mann-Whitney U-test. Within subject t-test, there we can write down Wilcoxon sign rank test. One way between subjects ANOVA, there you can use the Kruskal-Wallis one-way ANOVA. One way within subjects ANOVA, that is basically the repeated measurement. So here you can use the Friedman's ANOVA. So when it is written within subject t-test, that means the paired associated t-test. And when it is the within subject ANOVA, that means repeated ANOVA. Okay, next. Man-Whitney test, a researcher is interested in finding out if there are differences in teenagers and young adults. Levels of physical well-being rated 1 to 100. He recruited 10 teenagers and 10 adults for the experiment. In this case, the independent variable is the age group and the dependent variable is physical well-being. So in case of the Man-Whitney test, you have to uh, clearly define, that is, who is your independent variable and who is your dependent variable. Next. Assume that the data has multiple outliers, which is why the researcher opted to conduct a test. So when you find that is there are more number of outliers, that means that data are skewed in nature. There you can do the Man-Whitney test. In case of the Man-Whitney test, by using the SPSS, you will directly go to the non-parametric statistics. After that, you will click the this legacy dialog, and then legacy dialog, you have to select the two independent samples. Okay, next. Here is the Man-Whitney test. Here, physical well-being, that is the dependent variable, and the age group is the independent variable. Age group that will be categorized. So it is written that 1 and 2 is the two groups of the age. That is your independent variable. Next. So this is the Man-Whitney test. This is the result. In a Man-Whitney test, SPSS ranks the data. The lowest score of a physical well-being gets a rank of 1. The next lowest score gets a rank of 2. Okay, so from the lowest score, it gives the rank. The value here displays the average of the ranking. So here you can find out the mean rank, 13.45. And the sum of the ranks is 134.5. Because here the mean rank is considered. This is the sum of all rankings in each group of the independent variable. Man-Whitney, you scored 20.5 and P-level 0.03. Given an alpha value of 0.05, there is a significant difference in teenagers and adults' self-reported physical well-being. Looking at the mean ranks, on average, teenagers reported higher physical well-being than adults. So here you can find out the teenagers' mean rank, that is 13.45, and in case of the adult, it is 7.55. Therefore, you can tell that is the teenagers, their physical well-being is better than the adult. Okay, next. Next. Now we are coming to the within subjective test. And in case of the non-parametric, that will be the Wilcoxon sign rank test. A researcher wants to find out if implementing a reading program will help improve reading speed. So reading program will help improve reading speed. The researcher recruited 50 participants to enroll in the reading program and recorded their reading speed in seconds at two time periods before and after the reading program. That means it is just pre-post research design. In this condition, you can use the Wilcoxon-Sandang test. That is the, again, you will go to this non-parametric test. You have to select then the legacy dialog. After that, you have to think of the related sample because here you are dealing with the within group. Okay, that means the pre-post design model. Next. So, yes, move the pre-test and post-test and be careful. In this window, you have to show which variable is pre-test and which variable is the post-test. But in case of the ANOVA, with independent and dependent variable, where the assumption is not the paired, at that time you have to show only the dependent variable and the categorized group of the independent variable. But here, approach is different. Here, since it is a paired t-test, therefore you have to follow the pre and the post. Accordingly, you have to arrange your data. And after that, you have to click the Wilcoxon. Then OK. Next. So this is the Wilcoxon-Sandang test result. Here you will find that it is significant. And the pre-test and post-test, both the data mean rank is available here. The legend shows how negative, positive, and tied ranks are calculated. For example, there are 9 cases where a post-test score is lower than a pre-test score. This means that in 9 of the 10 participants, reading speed improved after intervention. We are interested in the test statistics, which is 2.70. Do note that in this case, the value is based on positive rank. P-value is 0.007. Given an alpha value of 0.05, it is a significant difference between pre-test and post-test score. Based on the mean ranks, participants' reading speed improved after the reading program. That means the reading program has the effect on the reading behavior. Okay, thank you. Next. Yeah, now we are coming to the, so between group is between subject t-test, within subject t-test. After that, we are coming to the one-way between subject ANOVA. Here we can use the Kruskal-Wallis one-way ANOVA. Kruskal-Wallis one-way ANOVA is very, very useful when you are not able to use the one-way ANOVA. ANOVA means analysis of variance. Okay, and analysis of variance. In case of the parametric test, it requires some of the important assumptions, that is the randomness of your subject assignment across the different groups. But in case of the Kruskal-Wallis, that assumption is not there. Therefore, you can use the Kruskal-Wallis one-way ANOVA. Next. Kruskal-Wallis one-way ANOVA, researcher is interested in finding out if there is a difference in physical well-being rated 1 to 100 among teenagers, young adults, and seniors. He recruited 10 teenagers, 10 adults, and 10 seniors. So 3 groups are there: teenager, adult, and seniors. for the experiment. In this case, independent variable is age group and DV is the physical well-being. So three groups you will find: teenager, adults, and seniors. And the rating is from 1 to 100 about the physical well-being. Next. Like others, you have to go to the non-parametric test, then legacy dialogue. After that, K independent sample you have to follow. In case if you want to use the SPSS, then you have to do the same thing. Next. Yeah. So here you can find out, just like ANOVA, you will find the similar pattern, that two windows are there. One window is about the dependent variable, that is your physical well-being. Another one is the grouping variable, that is the age group. So three age groups are there. So you have to write down uh, the defined range is there. So your lower range is 1 and the maximum range is 3. If you write down, then automatically the program can understand you have the three groups. Next. Select independent sample, minimum is 1, maximum is 3. Next. Now the Krushkalwali's result is there. Krushkalwali's age is 7.50 and T level 0.024. Given an alpha value of 0.05, there is a significant difference between the teenagers, adults, and seniors' self-reported physical well-being. Now, here you can find out the mean rank. Mean rank is high in case of the teenager in comparison with the adult and the senior. And this is significant. Okay, that means age has the effect on the self-reported physical well-being. Next. However, although we know that there is a significant difference between the three groups, we do not know exactly what the difference lies. It could lie between teenagers and adults, adults and seniors, teenagers and seniors. To test this, we conduct a post-hoc series of man-Whitney tests to find out the answer. You can find out more on man-Whitney test in the earlier example. So if you want to find out that is where the actual difference high, then you can do the man-Whitney test. Just like ANOVA, you can use the t-test when you find that is the ANOVA is significant. So here you can do the same thing. Now the question comes, that is the Friedman test. In case of the Friedman test, assumption is just like the pre-post model, and here it is the same subject will be tested twice, before and after. And but here there will be more between groups can be there. For example, pre, during, and the post. So if there are three periods, and over the periods, whether the period has any effect on the dependent variable or not, then you can use the Friedman ANOVA. Next. A researcher wants to find out if implementing a reading program will help improve reading speed. The researcher recruited 50 participants to enroll in the reading program and recorded their reading speed at 3 time periods, before and after the reading program, and at 1 month follow-up. So they have considered the follow-up data also. Next. Just like others, you have to check the non-parametric test, after that legacy dialogue, and then the K-related sample. Here you have to select the K-related sample. Keep in mind that is you have to select the K-related sample, not the independent sample. Next. Yeah. Now you can do the pre-test and post-test and this 1 month follow-up. So these three things are there. So that will help you basically. You can find out the differences across the three levels. Next. So here you can find out that there is a significant difference. High rank is 2.90, post is 1.6, and 1 month follow-up, it becomes 1.5. So you can write down the difference between the period also. That will provide you more knowledge. Another thing, here you can find out it is highly significant. The result is highly significant. It is 0.002 level. Next. However, just like Kruskal-Wallis test, although we now know that there is a significant difference between the three groups, we do not know exactly where the difference lies. Simply by eyeballing the mean ranks, we can probably guess that the difference comes from the improvement from pre-test to post-test, 2.9 versus 1.6, but not so much from the post-test to 1 month follow-up, 1.6 versus 1.5. To confirm this, we can conduct a series of post-hoc Wilcoxon sign-line tests. You can find out more in the earlier example on Wilcoxon. Thank you. Thank you. Now I am requesting Farah. Why I am requesting Farah? Because in this example, you have not noted any sort of economic behavior, and Farah has made another PPT where we will find how economic behavior, economic decisions are controlled by the social factor. Thank you, Farah. So I have already told you this thing, the introduction to non-parametric statistics we have understood from Akshita's PPT. And now I am coming to this very, very important. It is the exploratory type of data analysis, where we have to find out the chi-square between the gender and the payment method. So you know that people are using different types of payment method. Some are using credit card, some using debit card. Like that, there are different types of payment method in US. So we have to find out, that is, whether there is any difference, significant difference between the two or not. And we find that there is no such significant difference, no significant association between gender and payment method. So payment method is the economic behavior, and gender is the factor. And now this is the data visualization. Since it is almost census type of data, so for that reason, whether it is significant or not, that is not important because it covers the total population. This is not the sampling frame. So based upon the data, you can find out that is this pink color is the male and the blue color is the female. So I do not know what is the choice of para, because usually I find that is female prefer pink color and male prefer blue color. But okay, it is Fara's choice. And we have seen that is the between the male and the female. Male use different types of payment method more than the female. Particularly, they are very high in case of the uh, PayPal. PayPal, uh, in case of the PayPal, in case of the debit card. And if you think about the only the female, so they prefer less the debit card. I do not know what is the underlying reason. They prefer credit card and also the PayPal. That means they prefer to transfer money, that is the international transfer they prefer. And also they prefer credit card instead of the debit card. Debit card is preferred by the male. Okay. Now this is the R script. And here you can find out the R script is prop.table. Prop means proportion. That is the frequency of the proportion. One side is it is written 1. And here you can find out that is the more number of female, they are using PayPal, 18%, and the credit card also the 18%. And in case of the different payment method, male prefer cash and debit card as well as the PayPal. So no, not much difference except the cash factor. When you want to find out that is among the male, which payment method they prefer. But when you want to compare the male and female, then you can find out that is the male usually prefer the debit card and the cash. PayPal Hardmo. So there are different payment methods are there. Usually they prefer this type of payment method. Okay, in comparison with the female, but keep in mind it is not significant. So based upon the data, you cannot make any prediction. You cannot make any generalization. You can tell that this is the observation that you have noted. Next. Now it is the data visualization. And this typical type of bar plot. This is the which type of bar plot it is?
So stack bar chart.
This is the stack bar chart. So in that stack bar chart, you will find that is the male use more the debit card. Okay, so whatever the data you have already uh, seen, and this is the result. Now I am coming to the Spearman rank order correlation. That is whether the age and the review rating, uh, is there any similarity between the two? So for that reason, you can use the Spearman rank order correlation. This is the R script. You can use this one and you will understand. So this is the result. That is the review rating across the age group. So no noticeable trend. Next, you can find out the Kruskal-Wallis test. Acha, Phara, in case of the Spearman, you have
Yes.
to convert into the rank. It has not been converted into rank in Spearman rank order. Whatever your age is there, another one rating is there. So you have used the original data. But Spearman rank order correlation assumes that you have to rank the data. But you have not used the rank. It is the original data. Okay.
Yes, sir.
So please you modify this thing.
Okay.
It may not be correct. After that, the Kruskal-Wallis test already we have discussed. And here you can find out the shop behavior purchase amount and the shop behavior season. So whether the shopping behavior changes with the season or not, that you can get through this test. Next. And finally, Kruskal-Wallis test confirms that these differences are statistically meaningful, meaning consumer spending habits are influenced by the season. Then the Wilcoxon-Sandring test. Here it is the review rating and compare review ratings against a hypothetical median value of 3.5. So hypothetical median value is there, so expected value is there. And based upon that, you have to do this analysis. So here you can find out the hypothetical value is 3.5 and the data performs differently. But why hypothetical median? I'm not clear.
So
It is
result is
3.5.
that. So result is coming in that way. True location is not equal to 3.5.
So why I will think about that is whether it differs from the 3.5. What is the underlying reason? What is the underlying reason of Wilcoxon-Sandring test?
So it will tell you that how customers are rating in what way. So whether this will tell you that either they are rating high or low, low than 3.5. So in an extreme way they are rating, sir.
No, this is not clear to me. It is written V equal to 4819114. What is V?
This is our studio's result.
No, you have to be very clear. You have to find out what do you mean by the V and what is the why you have used the 3.5. Because in case of the species, we are not using any hypothetical data in case of the Wilcoxon sign line test. So please you check it thoroughly.
Okay.
So conclusion, non-parametric tests provide robust tools for analyzing data without strict distribution assumption. In this analysis, there was no significant association between gender and pen method. Negligible relationship was found between age and review dating. Significant differences in purchase amount were observed across season. The median review dating differed significantly from the hypothetical value of 3. So please you check this last one because I am little bit uh, not
Okay.
very sure because in case of the SPSS we are not using this type of thing. So
Sure.
why we'll use this thing? Okay,
Okay.
please you check. Mm.
Sure.
Oh, Suma now joined.
Yes, sir, I have joined from the chi-square test. Non-parametric tests, I missed it, but chi-square test onwards and Spearman's rank correlations, you were telling about that. I have heard about it.
Oh, that's nice. Okay. So there are some situations where uh, usually we do not follow any random sampling technique and there is a high possibility for the data skewness. So there we cannot use the mean directly. So in that condition, we can depend upon the non-parametric statistics. That is the advantage. And in case of the non-parametric statistics, my suggestion based upon my own researches that there should be more number of groups so that the DF will not be one, but DF must be more than one. Because when the DF will be close to the 30, that means many classifications. So as a researcher, your function will be to classify the observations into different categories. For example, simply the purchasing behavior, purchasing pattern. You can directly collect the data only the purchasing pattern, but instead of you are using the uh, purchasing pattern means whether purchased by credit card or debit card or cash or other techniques. So in this manner, you have to classify the observation into different categories. Then you will get higher DF. Okay, so this is very important. And keep in mind that is your chi-square, uh, in case of the chi-square distribution, uh, your observed frequency that should not be 0 and that should not be uh, very less. That means should not be less than 5. You always keep in mind the observed frequency should not be less than 5. because if it is less than 5, then it is better to merge the data with other group. So this is my suggestion. Automatically expected frequency will not be less than 5. Okay. So now is there any question?
So, the question regarding why we use median instead of a mean. So like we take non-parametric tests which may be considered as the distribution free tests. So when we consider mean, then we have the normal distribution. So normality assumption is something that we do not consider in this. So for that we can take median, and then we can go in for the difference of x1 x2, the variables, and then that difference the distribution of that difference is considered in non-parametric non-parametric tests sometimes. So the theoretical foundation may, I guess, that is the reason. We can also sometimes do the same thing in Man Whitney U test for because it is instead of paired t test and t test we use uh, the rank test, the man the second the first Wilcoxon test is also known as the Man Whitney, and the second Wilcoxon is also known as the rank Wilcoxon test. I think so. I'm not sure. I think that may be the explanation, but I don't know. Were the number of variables that were considered or something like that.
No, it is not
Because
the number of.
robustness also
The
increases
thing
the
is
robust.
that when it is non-parametric statistics, we are dealing with the score. But when it becomes the non-parametric, then we are classifying the data into different categories. The more number of categories will be there, that means it is close to the normal distribution. So if you want to find out the DF distribution, you will find the higher number of categories are there, and that is close to the normal probability curve. And less is the DF, then it is far away from the normal probability distribution. So why we are thinking about the normal probability? Because the normal probability will find all the categories of people, all the probabilities of the observation. We can find out in the normal probability distribution. For that reason, we always think about the approximate to the normal probability distribution. And when it is close to the normal probability distribution, then power of statistics that will be high. And when it is far away from the normal distribution, maybe you got the significant result, but the power of statistics is less. Okay.
Yes, yes, yes.
Therefore, categorization is important. Very, very important. And that requires the minute observation of the researcher. For example, when I have done research on the farmer self-efficacy, then I collected data from the government, and government provided me the list of the farmers. I collected data from them, and I observed that is the data is not reliable. Then I have noted, no, they are the farmers. Definitely they are the farmers, but they are the landowner. But they have no idea about the cultivation. Therefore, the classification is important. You have to find out that is who will be your actual population, and that population should be classified into the different categories. This part is vital. For example, you will find that is the patient, this whatever the data you have done, this physical wellness or something. So if you want to classify the physical wellness into different categories, then that will be better. Instead of the physical wellness from 1 to 100, and there is a rank from 1 to 100. So, and you have told that is this is the adults, but again adults has some category. Maybe some secondary information or the primary information. You can make the category. Categorization is very, very important. For that reason, you will find the normal probability distribution, and below the 0, 1, 2, 3 categories is minus side. Another one is 1, 2, 3 is the plus side. And you will find the total probabilities covered by the normal distribution. But that is not available in case of the non-parametric statistics. Therefore, you have to increase the power of statistics. So you have to follow the mode classification so that you can reach to the actual problem you can understand. Okay.
Yes, sir.
Okay, thank you, Akshita, for sharing the PPT. Para, thank you again. But Para, please you check this
Yes.
auction. Yeah.
Yes, I will question. I will check, sir. I'm just studying. Okay, sir. Okay.
Yeah.
Thank you, sir, for the feedback.
Okay. Thank you, Mona Lisa. Thank you, Soma. Now I am
Yes.
closing this session. Thank you.